Hello, I'm Chris Tomko, and today we're going to figure out how to do this problem. It says, find the value of the 6 trigonometric functions of the angle theta. We have a little right triangle there. We have theta right there, and then opposite side is 4. The hypotenuse is square root of 17. Now the first thing we're going to do is going to find what this other side is. We're going to do that by using the Pythagorean theorem, a squared plus b squared equals c squared, and c squared is the hypotenuse, so we have 4 squared plus b squared equals square root of 17 squared. And then you solve that and you find out that b is 1 and the square root of 1 is 1. That last side is going to be 1. And now we're just going to start off by doing the sine of theta. So katoa, sine is the opposite over the hypotenuse, the cosine is going to be the adjacent over the hypotenuse, and the tangent is going to be the opposite over the adjacent. When you do the sine, you're going to get 4 over the square root of 17, but you can't have a square root in the denominator, so you have to rationalize it by multiplying it by the square root of 17 over the square root of 17, or 1, and so the sine of theta is equal to 4 square root of 17 over 17. And for the cosine, when you do adjacent over hypotenuse, you get 1 over the square root of 17, so you have to do the same thing, multiply it by square root of 17 over square root of 17, and you get the square root of 17 over 17. For tangent, you just do opposite over adjacent, you get 4 over 1, so tangent of theta is 4. For the other three, cotangent, secant, and cosecant, we're just going to take the reciprocal of tangent for cotangent, reciprocal of cosine for secant, and the reciprocal of sine for cosecant, because that is how you do that. Once you do that, you figure out that the cotangent of theta is 1/4, the secant of theta is the square root of 17, and the cosecant of theta is the square root of 17 over 4. That's it. You're done.